looking at this sequence, can we define the rule for the nth term? Can we define the rule for the nth term, the nth term of this sequence?
30?
No. So what will be 100th term? The number on the 100th place in this sequence, if I continue to...
100 over 3.
It would be 100 over 3. What if it's a nth term?
N over 3.
N over 3.
Oh.
You see how I was able to come up with the rule for the nth term, right? And formally write it down. So this is kind of my function for the sequence term, n over 3. So what do you think the n plus 1 term would be? So this would be a n plus 1. That would be n plus 1 over 3, but nice. Right? So the index tells me the place in the sequence, and the formula allows me to calculate what the term actually is.
Okay.
Perfect. Finally, is this sequence finite or infinite?
Infinite.
Infinite.
Jinx.
Because I didn't tell you that it will end at some point. It goes forever and ever unless I specify that n is between some numbers. Okay. So as we saw right here, right, we were able to define the rule for our sequence like this: an equals n divided by 3. Well, actually, there are two types of rules that are used to define the sequence. One is called the recursive, and one is called the explicit. So let's first talk about the explicit rule because you've just seen it. If the formula for the for the term an, right? So if the formula that defines the term an based only on n, on the place in the sequence, then that formula or that rule is called explicit rule. So if we think about the example just above, right here, 1 over 3, 2 over 3, 1 over 3, 2 over 3, 3 over 3, 4 over 3, and so on and so forth, we see that the rule for the term an would be n over 3, and it only depends on n, on the place of the term in the sequence. This kind of rule is called explicit rule, only based on the on n.
Wait, I have a question.
Uh-huh.
So, an equals n over 3, is that...
The rule, that's the formula.
So, is that only for infinite, or can that be used for finite as well?
Finite, yes.
Finite.
It could be used for finite, but this particular rule is only for this particular sequence,
Okay.
right? It's not for every sequence.
Okay.
Every sequence will have its own pattern, its own rule, its own formula.
Okay.
So the sequence could also be defined with the recursive rule, and that is the rule that makes each term depend on the previous one or previous two or previous something, right? So recursive rule, in the recursive rule, terms are defined by their preceding terms. So if you think about the example we had in the warm-up, so we had 4, 7, 10, 13, and so on and so forth. You see how every next term depended on the previous term, and then we added 3, right? So if I wanted to define the rule for an, I would have to know what the number is in front of this term, and then add 3 to it, correct? So you see how I'm defining my a1 is 4, my a2 is a1 plus 3, my a3 is a2 plus 3, so on and so forth, an equals the previous term plus 3. Do we see this?
Why is it an minus 1?
Because the n minus 1 tells you where in the sequence this term is, right? So it's in front of an.
Okay.
Correct?
So if you were to switch it over, it would become plus?
Yes. So I could also say an plus 1 equals an plus 3, right?
Alrighty.
So every next one is the previous one plus 3, right? So this kind of rule is called the recursive rule. And don't forget, if you define the sequence with the recursive rule, you have to start somewhere. And that is why we say, in order to write recursive rule, you must know the initial term. Okay? So, do you know the Fibonacci numbers?
It's what?
Fibonacci numbers, Fibonacci sequence?
I don't know what that means.
Oh, that's okay. So, that's like one of the most famous sequences, I guess, right? And it, yeah, so you start with first numbers that are given to you. There are 1 and 1, right? So the first one is 1, and the second is 1, and then every next one is the sum of the previous two. So 1 plus 1 2, 1 plus 2 3, 2 plus 3 5, 3 plus 5 8, and so on and so forth. And you can read about it. It's like you can see it in nature. It's really cool
good
sequence.
Lord.
But we don't have time to talk about it. Fibonacci. I used to be obsessed with Fibonacci numbers.
Do you know it by heart?
Well, I mean, it's easy to calculate.
Yeah, it's
Okay. Oh, but for those of you who are interested in art, if you divide every term by the previous one, that ratio becomes closer and closer to the, what it's called, the number, the perfect number of the universe.
0.
No,
42.
no.
42.
No. What's it called? In like art and everywhere you use it. What is that called, the number?
42. Jackie Robinson.
No.
Point of view?
Field of Death.
Doesn't,
Ask
oh my God.
Marissa. Ask Marissa. She probably knows.
Anyway. So, any questions about this first page? Sequences, index of sequence, what does it mean? Fourth term of the sequence?
Magic.
Huh?
42.
Alright. So in this class we will talk specifically about two types of sequences, arithmetic and geometric. And I was told that you've done this before, you've seen some of this before, right? You know what arithmetic sequence is. Sequence is arithmetic if the difference between any two consecutive terms is constant. So the constant difference is called the common difference. Common difference. I should make sure I don't write it. Common. And in this class it will be denoted by T. So the sequence A1, A2, A3, so on and so forth, AN, so on and so forth, is arithmetic if there is such a number D such that A2 equals A1 plus D, A3 equals A2 plus D, A4 equals A3 plus D, and so on and so forth. And every term of the sequence AN equals AN minus 1 plus D. So the previous term plus the same number D, common difference. So what kind of rule is this? Recursive or explicit?
Recursive.
Recursive rule, right? Because to know my term AN, I need to know the previous term. So this would be recursive rule. So in arithmetic sequence, to find common difference D, you always do what? How do I look at my numbers? How do I figure out what is my common difference? What do I need to do? If I have 1, 3, 5, 7, 9, does this look like arithmetic sequence to you?
Could you put it into the calculator through like the
No calculators. Look at this. Does this look like arithmetic sequence to you or not?
Yes.
Yes, because from every term to the next one it's what? Plus 2, plus 2, plus 2, plus 2. So how do I find the common difference looking at my sequence?
you add 2.
I need to find the difference. So I take one term and minus previous term, right? So it's term minus previous term.
Okay.
For example, I can take A3 minus A2, right? Or A5 minus A4, or A10 minus A9. Term minus previous term, previous.
So 5 minus 3.
Yeah, so in our case, 5 minus 3, or 7 minus 5, or 9 minus 7. That would be my common difference. So for my example, what is D?
2.
2. common difference for this arithmetic sequence is D. Perfect. So let's practice. Decide whether the sequence is arithmetic. If so, find the common difference and write the next term. Let's do the first one together. How do I decide whether this is arithmetic or not? What do I need to check? Subtract. I need to look at every pair of consecutive terms and figure out what the difference is. Make sure that it's the same. So 7 minus 4 is 3. 10 minus 7 is 3. 13 minus 10 is 3. 16 minus 13 is 3. Right? So yes, we make a conclusion that yes, this is the arithmetic sequence, and D is what? 3. And the next term, which is what? Which term? 1, 2, 3,
It's
4,
19.
5. A6, 6 is 19. The sixth term of this sequence, A6, is 19.
Do you want us to practice writing
Yes.
those out?
Yes, I want you to practice writing it as A6, so that you get used to using this notation. Okay, now you do the rest.
I have a question.
Yes, A5 is a close 11.
No.
For number
No.
3, is it yes or no?
No.
No, right? Because look, A2
no
minus
for me.
A1 is 9 minus 8, which is 1. A3 minus A2 is 12 minus 9, 3. So they're not the same. The difference between these two is just 1, but the difference between these two is 3. Not the same difference, not arithmetic sequence. And number 4, is it yes or no?
Yeah.
Yes.
Yes.
D equals 1/4.
D equals 1/4
Five.
A
or
to the fifth equals
0.25.
Or A5 equals 2.
A5 equals 2. Everybody agrees? Questions? Okay, explicit rule. So as we said, the formula that, or the rule that we define for arithmetic sequence, this kind of rule is called recursive, right? How do we find the explicit rule for arithmetic sequence? Think about it. If I think about arithmetic sequence, A1, right? A1, A2, A3, A4, so on, AN, so on. A1, just give it to me, equals A1. A2 equals A1 plus D, correct? Right? We add D plus D. So plus D. A3 equals A2 plus D, but I could also say it's A1 plus how many Ds?
Two.
2 Ds, right? I start with A1 and then I add D and I add D again. So A1 plus 2D. A4 equals A3 plus D. Previous one plus D, so plus D. I could also think I started with A1 and added how many Ds?
3.
3D.
Wait, do you want us to write all of this down?
No, you don't have to. You'll just write the formula. I just want you to understand where it comes from. What if I'm asking you about A100? Right? I could say that it's A99 plus D, but if I start with A1, how many Ds will I have to add? 99 D. Right? So it's like add 99 times. 800 equals A1 plus 99 times D. D times 99, right? So what if I want to write a formula for AN in these kind of terms? I start with A1 and add D how many times?
And D.
N or less? If my N is 100, I'm adding 99 D.
Oh, N minus 1.
So N minus 1. So this is the formula that you need to get very familiar with. This is explicit formula. You see, as long as I give you A1 and D, all you need to know is N, right? With the recursive formula, to get to 800, you would need to calculate 99 terms that come before the 100th term. But with the explicit formula, you can do it in like one single step, right? As long as you know N, some parameters, you're good to go.
Wait.
Make sense?
Okay, I have one other question.
Uh-huh.
Sorry.
Let's practice. Okay, so far so good?
Yes.
The formulas are on your SOL formula sheets, but you have to still get very familiar with them. So let's practice. Write an explicit formula for the nth term of arithmetic sequence and then find 20th term. So please read the instruction on the quizzes and tests. This question has two parts. So formula for the nth term and then the 20th term. Two parts to it. There are two answers that you need to provide to us, which I didn't in the first period. Okay, so looking at this sequence, we don't even need to check because we are told this is arithmetic sequence. So what is my D?
It's 2, negative 2.
Negative 2, right? So I take any two consecutive terms and find the difference. So for example, A2 minus A1 equals 0 minus 2, so negative 2. My D is negative 2. Difference between every two terms. And my A1 equals what? My A1, the first term?
2.
2, right? The first term in the sequence.
Okay.
So now let's think about explicit formula. AN, generic formula is A1 plus N minus 1 times D. So I know my D, I know my A1. Let's plug them in. So AN equals A1 is 2 plus N minus 1 times my D is negative 2. And now I just need to simplify a little. So see? N minus 1 times negative 2, I can distribute the 2, negative 2. So equals 2 minus 2n plus 2, correct?
Yeah.
Simplify a little more, there are some like terms. So 4 minus 2n. So now this is the explicit formula for the nth term of this sequence, and it only depends on n, right? So I can easily find what A98 is.
Do you need to put it?
Anton. Okay, so we figured out the explicit rule for our arithmetic sequence, which means the formula for an that depends only on n. Explicit rule. However, there is second part of this problem, find 20th term. So now that I have this lovely formula, my 20th term A20 could be found using this formula with n equals what? 20, right? So I just use my formula to find A20, and I know that my n equals 20 here. So 4 minus 2 times 20, which is 4 minus 40, which is negative 36. So A20 is negative 36. So now I'm done with my problem. Explicit rule, 20th term. Questions? Okay, do number 6.
Let's see.
Okay, so how do we go about it?
Look.
The explicit rule, the generic formula that we just learned, AN equals A1 plus N minus 1, right? Correct? So, to write this formula, I need to know the numbers A1, A1, right? Okay, fine. So A1 and D, right? So that my formula only depends on N, explicit formula. So looking at my sequence, what is my A1?
10. Oh, wait, 1/2.
1/2 is
Sorry.
the first term of the sequence. What is my D?
10.
5. So it's the difference between two consecutive terms. So 11 over 2 minus 1 over 2 is 10 over 2, which is 5.
I do not
So
appreciate
D
that.
is 5. So I know A1, I know D. Now I can plug them into the formula. AN equals A1 is 1/2 plus N minus 1 times 5. To simplify, I just distribute 5 in. So 1/2 plus 5n minus 5 can simplify more. 5n minus 9 over 2. If fractions scare you, calculate them. 1/2 minus 5 is negative 9 over 2. So this is the explicit formula for the nth term of my arithmetic sequence. Questions? Now, how do I figure out what my 8/20th is? 8/20th, I can use this formula with n equals what? How do I, when I use this formula to find 8/20th, my n, just n, not n minus 1, n is 20, right? So 5 times 20 minus 9 over 2, and then we just evaluate, and that is what?
I got 8 to the 20th equals 191 over 2.
191 over 2.
What is it? When did it do?
And that is my answer for 8/20. Questions?
Why did it put it 4?
Moving on.
She just gave me 6.
Okay, so the next two, same idea, just a little bit different information to start with. Siobhan, pay attention. This is a little bit different, so pay attention. Same question, right? I need to find a n and I need to find a 20th, right? So a n, what I know is that the generic formula looks like this, right? So what I need to find out is a1 and d. Well, which one is given to us? D equals -3, nothing to do. But a1 is not given. I don't know a1, right? However, how will I find a1? I will use my generic formula and the information that I have. You see I have a49, right? So I will use, if I start with an equals a1 plus n minus 1d. For n equals 49, I can substitute all this information into my generic formula. So a49 is -112 equals a1 I do not know plus n is 49 minus 1 times d I know -3. See what I'm doing? Starting with generic formula, and then for n equals 49, I know what the term is. Yes, so I know what d is. So I'm substituting everything in.
Why do you have n minus? Okay.
Right? So now I can solve for a1. Correct? So just solve an equation as always. 48 times -3 is what? 1.
-144.
-144, and that equals 112, -112. So plus 144 plus 144 on both sides. And that gives us a1 equals
32.
32. Perfect. So now we found a1, 32. Now I know a1, I know d, I'm pretty much done. I can write down the formula. So explicit rule is an equals a1 is 32 plus n minus 1 times -3. Now I just need to simplify a little bit to write the final answer. Sorry, it's smaller and smaller. So I distribute -3 into parentheses and we write 32 minus 3n plus 3. Combine like terms. 32 plus 3 is 35 minus 3n. So an equals 35 minus 3n. So what we did, we used the generic formula, used the information that we had for A49 and for D, solved the equation for A1, and then we know A1, we know D, we can figure out the explicit formula that depends only on the index. Good? No? No. No, where did I lose you? Nowhere in particular, just confused. Using this formula, we can find 820, right? So how do I find 820? Use my formula, and instead of n, I plug in what? Instead of n, I plug in what for 820?
20.
20. So A20 equals 35 minus 3 times 20, which is, given, which
I got
is
negative 25.
negative 25.
Yeah.
Yes, negative 25. So 820 equals negative 25. I know we don't give you a lot of room here. Should have give it more room, but use scrap paper. Happy. Okay, try to do number 8. Okay, so once again, we need to find the formula for an, right? We need to find this formula an equals a1 plus n minus 1d, but we need to find the d and a1. So a1 equals and d equals. I need to find these two numbers to define my sequence. So which one is given to me? It's d, right? D equals 4, but I do need to somehow figure out a1. I don't know A1, however, I do know, so how to find out A1? I do know A7. So, see, if I just start with my generic formula, AN equals A1 plus N minus 1D. If I take my A7 equals A1 plus 7 minus 1 times D, right? So for A7, I use 7 instead of N. But I do know what A7 is. It's 16 equals A1 I do not know. 7 minus 1 is just 6 times D I do know it's 4. Now I have the equation with just one unknown, so I'll solve it. So this is 24. Very carefully just solving the equation. Minus 24 minus 24 on both sides gives me A1 equals negative 8. Are you with me? So A1 equals negative 8. Now I know both of them, A1 and D. That defines my arithmetic sequence. As long as I know the first term and the difference, I'm done. I know what to do, how to find the arithmetic sequence, right? So I use, to find the explicit rule, I take my formula, right? So explicit formula, I start with just generic n equals a1 plus d times n minus 1, and then substitute a1 and d. a1 is negative 8 plus d is 4. So an equals negative 8 plus 4 n minus 1. You have to simplify, otherwise points taken off. So distribute the 4 in. An equals 4n, and then minus 8 minus 4 is minus 12. Did I make a mistake? So 4n minus 12. That's the explicit rule for this sequence. An equals 4n minus 12. Questions? Then I can use this formula to find A20, because A20 is just this formula with n equals 20, so 4 times 20 minus 12, which is 80 minus 12, which is 68. So A20 is 68. Questions? You don't need to practice this, but we need to move on. Oh no, we have one more. Right. But you will practice more with this at home. Now the last one. The idea is exactly the same, but here you have different information again, right? Again, I need to figure out my formula for an, so I need to know a1 and d. Do I have any of these given to me?
Nope.
No, right? Not a1, not d. However, I know a6 and a22, so I will just set up two equations instead of one, right? Using that same formula, the one that you've written hopefully right there in that box, the empty box, shouldn't have left it out empty. So anyway, for A6, right, I use 7 equals A1 plus n minus 1 and 6 minus 1, 5 times D. Do we see where this came from? A7, this is for A7. So A7, oh, I'm sorry, A6. A6. So A6 is 7 equals A1 plus 6 minus 1, D. And then I use A22 to set up second equation. So A22 is 87 equals A1, which I don't know, plus 10 minus 1 is 22 minus 1, 21, D. And I have a system of equations that I hopefully know how to solve. Either substitution or elimination method. Right? What's easier?
Elimination.
Let's do elimination. See how I can subtract one equation from the other? Do we see it? Yeah, I'll subtract the first from the second. So 87 minus 7 is 80 equals A1 minus A1 is 0 plus 21 minus 5 is 16D.
16.
So 16D equals 80. Divide by 16, divide by 16 gives me D equals
5.
5. So now I know D. Halfway there. D is 5. Now I will use this D and plug it back into one of these equations. So I'll use the first one. 7 equals, right? So I'm using these and these. 7 equals A1, I still don't know, plus 5 times my D is 5. See? Equation with just one unknown. So 5 times 5, 25. Another little equation. Minus 25 minus 25 on both sides gives me A1 equals
8. Negative 18.
negative 18. So negative 18. Perfect. As long as I know my system is arithmetic sequence and I know my first term and I know my common difference, I'm pretty much I know the sequence, right? So all is left, use these numbers, plug them into my generic formula. So AN equals A1 is negative 18 plus n minus 1 times 5. And now I can just simplify by distributing first and then combining like terms. So this will give me 5 and minus 18 minus 5 is minus 23. So here is the explicit rule for this arithmetic sequence. Half of the problem done. Questions? You need to set up both equations here because you have two unknowns, A1 and T, right? So just one equation you cannot solve for both A1 and T. That's why it's important to set up the system.
Okay, so because you, how do I get this in the word? Because you did all that to get D equals 5, do you have to use both equations now?
After this step,
There's two equations and we're just working on 7 equals whatever. Are we going to have to do the 87 equals whatever, or can we just stop at 7 equals whatever?
I'm not sure I understand the question.
No, you have to do both if you want to find the common difference.
Right? You have to, because just one equation with two unknowns you cannot solve. Because you have two unknowns, you need to have two equations.
She's asking about the AN. She wants to know if you need to do a separate one for the 87.
Oh, it's just saying after you find D, you have to plug it in for both of them? Or
No,
Just
no, just one. Because remember how we solve the systems of equations? You choose any of these, plug D back. It doesn't matter which one to use, you get the same answer for A1. Any other questions? Okay, so we still need to find A20, right? And we can use our formula, just plug in 20 instead of n. So 5 times 20 minus 23. So A20 after I evaluate will give me
77.
77. And we are done with the arithmetic sequence. We'll have a lot of practice with this at home. Can we move on? Second half of the lesson, or I guess third, geometric. So what is the geometric sequence? You hate geometric sequence? Come on.
Geometry.
Oh, it has very little to do with geometry. So sequence is geometric if the ratio of any term to the previous term is constant. Right? So instead of adding the same number, we are multiplying by the same number. Correct? So the example would be what? Give me an example. Luis, give me an example. We'll start with 1 and then 3 and then I think 7, right? So times 3 times 3 times 3. So if we start with A1, we can choose anything for the first term, and then we choose our common ratio, which we denote by R in this class. So in my case, or in Louis's case, he chose R equals 3, right? So he's multiplying by 3 every single time. And that becomes the geometric sequence. So the sequence A1, A2, A3, A4, and so on is geometric when there exists such number R that you go from, the ratio between every two consecutive terms is R. So A2 equals A1 times R, A3 equals A2 times R, and so on and so forth. So to find the common ratio, you would find the ratio between two consecutive numbers. So just take any term and divide it by the previous term. For example, you could say A5 divided by A4, or A3 divided by A2. Doesn't matter. Two consecutive terms. Adeya, are you with us? Let's practice. Is the first sequence geometric or not? How do I find that out?
Divide by
Yes.
3.
Divide
Yes,
3 by
so
negative 9.
I have to check every
No,
pair of
it's
consecutive
3.
terms. So
You
No,
divide
but
a
how to
negative by a
find
negative.
negative 3
Positive.
divided
No,
by
but how to
negative
find it?
9.
Mhm.
Term divided by previous term, right? So times 1 over 3. You see what I'm doing? So A2 divided by A1 equals negative 3 divided by negative 1, which is 1 over 3.
You mean negative 9? You
Yes.
said yeah.
Negative.
You said negative 3 divided by negative 1.
Wait, why is the
Oh,
2 on
negative
top?
9. Why is what on top?
Why is A2 on top instead of A1?
Because you divide this term by the previous
Yes,
one.
because we are multiplying by the same number, right? To find that number, you need to take the term divided by the previous one. So A2 divided by 1, A3 divided by 2.
Why would you go that way?
Okay, so we need to check every single pair. So negative 3 divided by negative 9 is 1/3. Negative 1 divided by negative 3 is again 1/3. Negative 1 over 3 divided by negative 1 is again 1/3. They all seem to be the the ratio seems to be the same, correct? So yes, this is geometric sequence and the R equals 1 over 3. Check the next one.
R
You,
equals 6.
huh?
R equals 6.
Ava, so is it yes or no for the second? Did you check?
No, not yet.
Not yet.
R equals 6.
It's yes, isn't it? Because you're multiplying by 2.
R equals multiplying.
So we have to check every single pair. A2 divided by A1 is 1 divided by 1/2, which is 2. A3 divided by A2 equals 2 divided by 1, which is 2. And we continue and continue and continue. We check every single pair. 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2. So the answer is yes, and R equals
2.
2. Perfect.
How would it be no? Can we see an example of a no? That
course.
the sequence is not geometric.
So let's think about the example which is not geometric sequence. What if we start 2, 4, 8, 12. Is this geometric sequence or not?
No.
No.
No, because 4 divided by 2 is 2, right? So this would be 2 times 2. 8 divided by 4 is 2, so times 2, very good. But 12 divided by 8 is not 2, right? 12 divided by 8 is a fraction,
3 halves.
3 halves. So times 3 halves. See, the ratio is not the same for every pair of consecutive terms. So this one is an example of no.
We do the next term.
Oh yes, see, I'm always forgetting. Okay, so for this one, sorry about that. See, learn to read the instructions. If so, find the common ratio and write the next term. So for the first one, the next term is a what? What is the index for the next term?
A6.
A6. And the term is negative
1 over 27.
1 over 27. Right? We take the last one, negative 1 over 9 times 1 over 3. Negative 1 over 27. What about this one? Questions how I found it. So just take the A5 times 1 over 3 gives me negative 1 over 27. So for this one, for this one, A 1, 2, 3, 4, 5, 6 equals what? 8
16.
times 2 equals 16.
16.
So I take A5 multiplied by my R, which is 2, 16. Now explicit rule. So this was the recursive rule again, right? Because for this rule, how we define this sequence, an equals the previous term an minus 1 times r. This is recursive rule. Now let's figure out what the explicit rule for geometric sequence is. So think about it again, right? If I start with the first one, if I have a1, a2, a3, a4, and so on. So the first one is just, a1. To get the second term, I multiply by r. So a2 equals a1 times r, correct? a3 equals a2 times r, or starting with a1, how many times do I multiply it by r? 2 times, right? So it's a1 times r to the power of 2, correct? You see? If I do this again and again, what will be my a100? It's a99 times r. But if I don't want to calculate 99 terms before I get to 800,
8 times r to the power of 99.
a1 times r to what?
The power of 99.
To the power of 99, because I start with a1 and then I multiply it by r 99 times before I get to the 100th term. Right, so if I, please write this down in your notes, even though it's on the formula sheet. an equals a1 times r to what?
N over N minus 1.
an minus 1, very good. Where an is the nth term, a1 is the first term of my sequence, and the number of terms, and r is the constant, the common ratio. Questions? Now the same kind of problems that we did for arithmetic sequence, just geometric sequence. So we do remember that an equals a1 times r to the power of n minus 1. To write the explicit rule for an, what you need to know is a1 and r, right? So use whatever information you have in your problem to figure out a1 and r. The set of equations you need to set, whatever you need to do. Find a1, find r, plug them back into this generic formula, get your explicit rule for this sequence. So the first one is quite easy, right? What is my a1? Gabi, what is my a1? Negative 5. What is my r? How do I find r, Gabi?
Negative 2.
Gabi, how did you find that? Split. Well, multiply what by what? right? But to actually get the formula for R, I need to divide some R. Yeah, so for example, 10 divided by negative 5. So choose any two consecutive terms, could be negative 5 and 10, could be negative 20 and 40, whatever, just two terms that are next to each other. Divide the later by the earlier. So negative 2. Once I know my A1 and R, I'm pretty much done. All I need to do to plug them back into the formula. So AN equals, A1 is negative 5 times negative 2 to the power of 10 minus 1. That's it. My explicit rule is done. Nothing even to simplify for geometry, even easier. So explicit rule is written. Now, let's do the tens term, not 20s. Numbers are too large. So we'll do find the tens term. So 8 tenths equals, now I use my formula, negative 5 times negative 2 to what power?
9.
9. And that gives me what? Answer? Somebody? I have 25, 60.
So about 60.
That's it? Yeah.
Minus 5.
Minus 5. What? Negative 5
That's
times.
A1.
No, because it's times. So you put that in. No, you just put it all in times. They're all multiplied.
Yes.
So when you,
Times.
when you explicit rule,
Two.
why is
To
the,
the one.
why is the exponent n minus one instead of just n?
Because that's our formula, right?
Because I don't like this.
Because remember, if I go here from A1 to A2, I multiply A1 just
Going
once
backwards
by
and
R.
forwards, and I don't
So
like
instead
that.
of 2, I have here 1, right? To get to A3, I start with A1 and multiply it by R. So A1 times R squared. You see A3 equals A1 times R squared. See 3, 2, 2, 1. If I generalize this, I start with A1 and multiply it by R n minus 1 times to get to AN. Right? So it's not AN, not n times, n minus 1. So that's the answer. Questions? Do the next one by yourself. Forgot it. Okay. So number 6. Once again, we need AN and we need A10. So what I really care about is the first term A1 and my R. Look at what I have in the beginning of the program. They gave me 6. So R equals 6 done. I still need to figure out what A1 is. I don't know what it is, so I need to find it. But I do have A3. Right? So for A3, if I plug in everything I know into my generic formula, what I'll have is 72, which is my A3, equals my A1, which I don't know, times my R, which is 6 to the power of n minus 1, n is 3, so to the power of 2. Do we all see how I created that equation? I used my AN equals, or A3, right? So if I start with AN equals A1 times R to the power of n minus 1, then for A3, I will have A1 times R to what power? 3
2.
minus 1, right? So 2. See, start with generic formula, Jaden. Then, since I know A3, A third equals A1 times R squared, correct? Because I start with A1 multiplied by R. Just plugging in my n is 3. So 3 minus 1, 2. But now I do know what A3 is, 72, and I do know what number R is at 6. That's how I get this equation that I can now solve for A1. Correct? So now, so this is like how we got it, so I'll delete it. So now I can solve this equation for A1. So 6 squared is just 36. 172. Let me put just so this is my A13. This is my, oh, not 13. So this is my A3. This is my A1. This is my R to power 3 minus 1. Okay, so divided by 36, divided by 36 gives me A1 equals what? 2. Right? So A1 equals 2. Now I know my A1 and I know my R, so I can write the formula for AN. AN equals A1 2 times 6 to the power of n minus 1. And that's the explicit rule for this geometric sequence. So again, look at the generic formula. You need to know A1, you need to know R. So use whatever information you have to set up the equation, solve for what you need to solve, and you're done. So in the, wait.
Hold on.
There will, look at, these ones will not be on the quiz, but we still need to learn it, so you'll have some of this in the homework. But I want you to, I want to do this one. We have 2 minutes, so I want to do this one just
You
so
have one.
one more time we see the difference between explicit rule and recursive rule. So let's read, even if you're not writing. In an arithmetic sequence, A1 equals 5 and D equals -2. Find the explicit rule and find the recursive rule. Recursive means based on the previous term. So for the recursive rule, all I write is AN equals AN minus 1 minus 2. Isaiah, no. You don't leave before we tell you to leave. That means class. It's very disrespectful. Very disrespectful.
Guys, you have 7 minutes in between your classes.
Okay, next class it's